So in this video, I want to take a quick look at quadratic functions and get you familiar with them. You should remember a lot of this stuff from last year. Most of it we talked about a lot. Our goal, as you can see, is to identify the characteristics of quadratic functions, both in equation form and graph form. So let's start with the definition. By definition, a quadratic function is a function that can be, not always necessarily is, but that can be written in the form y equals ax squared plus bx plus c. And where a does not equal 0. If a were to equal 0, this whole term would go away, leaving you with something that's linear. So that's why a can't equal 0. This form is called general form. And most of the time we see quadratics written in general form, but not always. Sometimes you see them written in factored form, or what we'll get to later is vertex form. It's just that you can manipulate the equation and write it in that form. That's how you know you have a quadratic. Now this type of function is going to make a U-shaped graph, which is called a parabola. The highest exponent that you will see, this should say in the equation, not on the graph, in the equation, go ahead and make that change, is 2. It's kind of another clue that you're working with a quadratic. And every quadratic has a vertex on the graph. That's kind of like the turnaround point. It's either the peak or the valley. The vertex is a maximum, aka a peak, so it would open like this. And we call that opens down. And that's going to occur when a is negative. So if a is negative, that means it's less than 0. So anytime in this form you have an a value that's negative, that means that your parabola is going to open down, and that vertex is going to be a maximum. Now, the vertex is a minimum if the graph opens up. So if it looks like this. Okay, that occurs when a is positive, so a is greater than 0. In addition to always having a vertex, every quadratic is going to have a line of symmetry too. Probably one of the reasons I like parabolas so much is because they are symmetric. This line of symmetry is going to evenly divide that parabola in half, and the unique thing about it is it always goes to the vertex. So once you know where your vertex is, you know where your line of symmetry is. So just kind of taking a quick look at the graph here. On this graph, this parabola, this quadratic, we would have a vertex, which is a minimum. The vertex is at, looks like 2, 3, and it is a minimum. The lowest point on the graph. But my line of symmetry, I'll just do a dashed line here, goes through that point. So the equation for my line of symmetry, the line of symmetry is right there. The equation for that would be x equals 2, because it's a vertical line. Okay. So those are kind of your basic characteristics of quadratics. Let's get into vertex form. So vertex form is just another form of a quadratic. It looks different from standard form. It can tell us some different things about that quadratic. So vertex form is y equals some number a times the quantity x minus h, and that quantity squared plus k. Again, a does not equal 0. If a equals 0, this whole thing disappears and you just have a constant function. A, h, and k, they're just numbers. They're just placeholders for numbers. But if you have something that's written in this form, the vertex is so easy to find. It's just whatever number's in for h and whatever number's in for k. And there's your vertex. So if you look at the next example, we have to find the vertex of the following functions, and then indicate if we have a max or a min. Well, if you look at this first equation, this is not in standard form. It is in vertex form. Here is A, here's H, here's K. You know what, I'll just write that right underneath so you can kind of see how things line up. Okay, so this 2 in front, that's important, but it doesn't tell me where the vertex is. It's the H and the K that tell me where the vertex is. The vertex is going to be at 3, -5. The A, the 2 in front, because it's positive, that tells me that this parabola opens up, you know, like that. So my vertex is going to be a minimum. On the other guy over here, he's also in vertex form. Again, I'll just write that vertex form right underneath so you can kind of see how things line up. -1/2 is A, -2 is H, +3 is K. So my vertex is H, K. Oops, I'll just go ahead and then say that that is -2, 3. Now, that is a maximum because A is negative. So that means that it was opening down like, it was opening down like this. So that meant that the vertex was at the top. Okay, and that's your basic introduction to quadratics. We're going to be talking about some more of these things in a more detailed manner tomorrow in class, but you're done.